In this episode of the Automation Demo Show, Mark Berger of Siemens is going to demonstrate to us how to use one of their SIMACode devices with both a CompactLogix and an S7 PLC. Mark, thank you for coming back on the show. I'm looking forward to seeing SIMACode in action, and I'm excited to see you both connected to a Rockwell ControlLogix CompactLogix PLC inside of Studio 5000, as well as to a Siemens S7 PLC inside of TIA Portal. So with that said, let's go ahead and start the demo if you're good.
I'm ready. Thanks again for letting me come back and for part 2 of this. So just a quick reference, this is a Siemens motor control device that we put out there. And now let's, the key is that we're going to show conductivity with ControlLogix and Studio 5000. So let's start off with that out of the gate. I've got here where I'll create a new project. Now the hardware that I have is an L16ER. So I've already selected that. We'll just call this Innovations for the project name. Hit next. And then we have no modules. And I'm doing this in 35, but the files that we use to communicate, the EDS files and the UDTs, will work all the way down to version 21 of
Nice.
yeah, so it's not a problem, but I believe I'm using the latest and greatest right now of 35. Yep. Overwrite. Okay. So the key here is that once you open up the Studio 5000 Designer, we're going to import the EDS file for the SIMACode. And I've already done that, but just for those who have not done it, I'm going to step through it. Come up to Tools, EDS Hardware Installation. Hit Next, register it, find it. And there I have it here on my desktop. There's the file. Hit Open. Hit OK. Hit Next. There we go. Hit Next. Shows the picture. Hit Next. Next. And hit Finish. Okay, now that we've added the EDS file, we're going to right-click on Ethernet, add new module. And then there we're going to go look in the search, in the filters, and look for Siemens. Notice that 3 items came up. This is just FYI. This is my Ethernet IP card for my soft starters. So we have EDS files and UDTs for them. Here's the SIMACode. And then also we have a remote IO head module that will talk Ethernet IP.
Now I want to ask you a question here. When you added that EDS file a minute ago, that just added the one thing you selected, right? The SIMACode?
Correct.
Okay, you had added these other ones previously.
And using it in different projects. Yep, they came from other projects. So SIMACode, and hit Create. Then I'm going to give it a name. I'm going to call it Pump 203. And then I'm going to go to Network and add the IP address and hit OK. And then close. Now I've already started a project and put some logic in there. So for time constraints, I'm going to switch over to this project here. I've added some logic to where I have a remote switch. I have a start, stop, and then some light LED indicators for it.
Could you do me a favor? Could you go to the controller tags? I want to see the tags that were automatically generated when you added that to the IO tree.
So we go here to the Siemens. Oh, and in this case, I called the SIMACode OLEDS.
Okay.
So here's the inputs. And here's the outputs.
Okay.
And I'll show you the data here in just a few minutes.
All right.
So if we come up here, I go up to this guy. And you can see that I have the forward and stuff. And I will show the relation here in just a minute for the byte and the bits when I go in the SIMACode. So now I'm going to switch over to TIA Portal. This is TIA Portal, and this is the software that we program with. This is the envelope to where that the umbrella, as I said in the previous presentation, this is the portal is my umbrella that covers all the programming aspects of PLCs, HMIs, and drives. And I've already added a SIMACode into this project, but just to show how you add one, you go to New Device, And as I stated, here's your PLCs, your HMIs, your SCADA systems, your drives, and then here is my control devices. The software, as we stated previous episode, is free for the basic. If you are not programming any of this other stuff, then this is what would show up. But if you're using our PLCs and you want to use SIMACode, this would be the little postage stamp for that. And then it will be under Sirius Monitoring Control Devices. And then here's the SIMACode Pro and the basic unit, because that's what we will talk to. And then here's all the communication protocols that we have. For our demonstration right now, I'm going to use Ethernet IP. And I'm going to hit OK. And then what it's going to do is start a wizard for you. Because the SIMACode, yeah, it has some complexity to it. We want to make it easy for you. So what we do is initially out of the gate, we create or start a template startup screen. And we're going to do the parameter wizard. And then it says, how do you want to apply it? How do you want to use it? Overload relay, direct starter, or reversing starter? So in my application, I'm going to do reversing starter. And I'm going to hit finish. And then now it just installed a template into the SIMACode of how you want to use it. And then here again, it says, are you sure you want to use it at reversing starter? And then it has some check boxes, thermistor, if you're going to use the thermistor and the windings. And then there's the installation module or initialization module that we talked about, one way of recovering or programming a new SIMACode that you swapped out. I'm going to hit next. Here's where I put in my full load amps of my motor. And for my applications, a 0.5 amp. And then trip class 520, see it goes all the way to 40. For my application, I'm going to go 20. And then cool down period. This is the time that you rest after an overload trip. I'm going to put in 60 seconds. That's the minimum. And then you can see here's an unbalanced protection and then a stalled rotor. But notice it's deactivated. All the settings that I talk about today is all deactivated, except the application that you've done is for an overload and using it as a reversing starter. So I hit next. And then, as I stated in the previous episode, I have a way of doing high and low, and setting that up within the SIMACode to where it could stand alone by itself. So if you're using a SIMACode by itself in a pump panel and you want to have a high and low process window, this has nothing to do with the overload, but process window for pressure, and we bring it in as a 4 to 20 milliamp pressure, then I can set this up as a process window. And you're able to control and give signals to let them know that if it overpressures or underpressures, like for instance, my friend where his pivot broke and a flange or a coupler broke and spraying water everywhere. So the demand for the pump went extremely high, but the load went away. So I was able to shut it off before it flooded his fields and so forth. And then we have some other options here where you have a motor operating hours. So you can go in here and put in 600 hours, and then you can have a signal and send a signal to the operator and say, hey, once the motor has ran accumulatively 600 hours, signal him, and then he can fill out a PM and schedule it down or let the maintenance department know that the motor has ran for 600 hours. And that's a way of doing your PMs on motors instead of like a calendar or anything like that. But we're not going to do that today. But notice it's deactivated and it's waiting there for you if you like to use it. Then I'm going to hit finish. Now what it's done is we're practically finished and using it. But when it adds it to the project tree here, I'm going to go to device configuration because we haven't told it that what it all can do. It does a bare minimum of doing a current draw. And let me zoom in a little bit. So right now we only have a CT. But let's say our customer wants to monitor voltage and current. So I'm going to change the device and I'm going to change it to a CT PT to where it monitors current and voltage. And hit OK. And notice that the 0.3 to 4 amp on this one's just 0.3 to 3 amps. We'll switch that out. And now you have L1, L2, and L3 for monitoring voltage. You have the Ethernet IP SIMACode. And then in my demo that I'll show in just a minute, we're going to have a digital module. And I stated that some plants use 120 volt control, and that's where we would use this digital module because the base unit only has 24 volt DC inputs, but this one has 120 volt AC inputs. And then I'm going to put in an analog module and put in a temperature module. So now I've built up my demo that I have here on the desk. I have the operator panel. If you don't, it's not required. If you're not going to use it, you can just delete it. Or if you want to leave it there, you can use it. That's great. So the last thing I need to do, because I've already got it configured as a full voltage reversing, I'm going to come to parameters again. And note, for those who've used Portal, the same icons, the same terminology, and the same look and feel of like our drives. This is what the icons are for our G120 series or our S120 series. I'm going to come over here and go to Ethernet parameters. I'm going to put in 20. If you remember when I did the configuration in Studio 5000, I used 192.168.0.20. And then I'm going to scroll down and I'm going to turn on the web server. The web server meaning the web page for the SIMOCODE. Now there's one big difference between the Ethernet IP and the Profinet, Sean. And the Profinet one has an OPC UA server built in. The Ethernet IP does not. That's the big difference of it. But as the setup and configuration of the Ethernet IP version or the Profinet version, it is exactly the same. The only things that really change is that minusing, there's no OPC UA server here, and then also the communication protocol. So now you said, you asked me about the bits and the bytes in the logic. So if you look here, this is where it comes into the logic. So with the Siemens, we call our cyclic data, where it's cyclically ascending and updating the process image. And then we have acyclic data. And correct me if I'm wrong, Sean, my terminology, but for Allen Bradley, that would be implicit and explicit data. So this is the implicit data that's coming into the Rockwell. So at bit 0, that's status clockwise or counterclockwise. Bit 1 is off, bit 2 is counterclockwise. So if I switch back to the Rockwell software, you can see bit here, bit 0, there's forward, stop here, and notice that it's byte 0. And then here's reverse, and then I continue to do remote, ground fault, or group fault, and group warning, which is coinciding with this here. Okay, so with that done, that's the setup. You download it to the SIMOCODE, and we're off to the races. Now, what I want to show next is demonstrating how we go about turning it on and off.
Mark,
Yes,
can
please.
you do me a favor? Could you
Anything.
please check the IP address in Studio 5000?
I'd be glad to.
I believe it was 1.20 here.
Yes, it was 1.20, and if
And
I switch over.
Yeah, I didn't
Oh,
see
you're
them.
correct. Thank you. There you go.
Now this is the second one you added, though. Is
correct. The one that is downloaded already is right here, and its parameters are the 1.20.
Oh, I see. Okay, you were just adding a second one just to show people how to go through the steps.
Exactly.
But the one we're actually using is the 1.20. Got it.
Yep, this one up here, and I can change the name so it matches it to the one that I put into. So I can call that a pump 203. Or or the one that was in the Rockwell was old LEDs, like that, and so I can have it match that. And so now you can see it put it in alphabetical order, and it's moved it down here.
Okay, good.
So yeah, the purpose here was to show you guys how to import it, but I've already done it here. I've already downloaded it to the demo that we're having. So I'm going to switch over here to the Rockwell software. I'm going to go over here to the main program, the routine, and you can see up here that I have,
Can you zoom in on that? Thank you.
Yep.
For the old guys like me.
Yep, I'm with you. I'm wearing my glasses as we speak. So there we go. So I've got now the remote data, meaning is that I'm doing a local data. I've got a selector switch, and I'm going to put it in. So for our terminology today, remote means that the DCS or the PLC is in charge. And then local means that the demo is, or maybe a local stop start at an MCC bucket or a stop start station at the motor. So then that bit 5 gets turned on, which if you look at the Siemens software, that bit 5 right here is remote mode. So I'm turning that bit high to remote mode. All of this was programmed when we did the template of the full voltage reversing starter. This was all programmed for you. But notice that also emphasize that you have some free bits and bytes that you can go in and whatever you want to have it do and communicate it over to the Rockwell PLC. If you have some like, for instance, a warning for a temperature, let's say that you're using a temperature, we can send bits and bytes for warning of the gearbox is reaching a too hot of temperature. Or in this case, I put an execution stop command, which means that I told the motor to stop running, but I'm continuing to see current flowing, which means that maybe I have one leg of my contactor welded shut. And so then that can give the operator and let them know that, hey, the reason why the motor hasn't stopped is that we may have a contactor, one of the legs of L1, L2, and L3 welded shut. So this is a free pad, if I can kind of free wheelie of changing the bits and the bytes in the byte 1 to whatever you want to bring across to the ControlLogix 5000. So I'm going to stop sharing and I'm going to show the demo. And it's set up. And then I will come over and operate it a little bit. So right now I have an operator station. And you can see that I've got a stops, counterclockwise, clockwise buttons. I've got a stop. I have the SIMACODE basic unit, the CT module that's measuring the current and voltage. And then I have my circuit protection up here. Right now that's just an MSP, which we can turn off voltage, return. And then down below I have a reversing contactor. So right now it's in charge of the local, so I can start it. I have my motor turning. I can stop it. You can hear a little bit of noise of the motor contactor pulling in. But now I'm going to notice that over here as I'm stopping and starting, that the lights are changing on the CompactLogix. That's because we're communicating over, letting them know status. But notice that I cannot stop or start with the CompactLogix until I tell it that I want to be in charge. The blue light means that it's in remote mode. And now I'm running it via the CompactLogix. And I can stop it. And then I can relinquish control again. Light goes off, meaning that I'm local again, and so forth. So, and that's the gist of it all, the communications for the Ethernet IP. So now, if you don't mind, Sean, I'm going to switch from Ethernet IP and show you the communicating with the Siemens PLC. I won't download it, but I wanted to show you what it takes to do it communicating with a Siemens PLC.
Yeah, excellent. Please.
Okay, so we'll switch over back to TI Portal. All right, return back to the TI Portal software. Now notice I have two SIMACODE Ethernet IPs in here. Of course, we're switching now to full Siemens. So I'm going to add a small PLC quickly to maybe our smallest one. We'll just go to a little 1211. And this one's, let's see here, if I remember right, it's 6 in and 4 out. And I'm going to hit OK. And I'm going to add that to my entire project. That's the power of TI Portals. I can put as many PLCs, HMIs, drives, SIMACODEs in this and be able to look at my entire plant or make it a simple project as one PLC and one HMI.
I would just caution the audience that, it's great to have a tiny PLC like this that programs just like the big ones, especially just like the S7-1500. Notice on the right-hand side, there's no expansion slots. So keep that in mind. If you ever pick the 1211, keep that in mind. You're getting what you're getting, and that's all you get, except for that the little board on the top.
That's exactly right. The little signal board here, and that's about it. The 1211 is just a quick small little guy for some little small. It's on the verge of being a smart relay is what it is on the 1211. But you move up into the higher 1200 series, then you're able to expand as much as you want.
A lot.
Yep. And if you look, you can tell that it's not going to allow you to expand because you have none of the rack over here. It's dead. There's nothing here.
Exactly.
So that lets you know. But my purpose in showing you is that the smallest little PLC can control via Profinet some good stuff. So now I'm going to switch to network view and show you what I have out there. Notice that the Ethernet IP SIMACODEs are up here. So I'm going to move them down and I'm going to move our PLC over here. Now I'm going to add a Profinet version of SIMACODE. So add new device. Go here, basic, and then I'm going to go here to Profinet, go to this guy, hit OK, and the same thing, same steps. So it's the same look and feel for both Ethernet IP and Profinet. And this one, do reversing, and hit finish, and go next. It's asking you sure you want to do this. Yeah, hit next. Here's the same screen, adding my full load amps. We'll drop this down 20. And if this looks like redundant, it kind of is because I'm doing the same settings as I did in the Ethernet IP. Hit next. Here's your process window, your high and your low, but we're not going to do that right now. And then here's your motor operating hours. I'll hit finish and notice that it added it here. So I'm going to come here and then I'm going to go double click and then I'm going to come right here. And now again, this is the current only monitoring. I'm going to switch that to voltage and current monitoring. Hit OK. And then I'll add the same items as I did in the Ethernet IP setup. So I come here for the digital module, analog module, temperature module, and I leave the operator panel right there. And then now I go over to parameters. And we'll make this Profinet parameters, and we'll make this 161, and go here and make it 21. And then scroll down, and then now I'm going to turn on the web server and the OPC-UA server. So as you stated earlier, the Profinet has an OPC-UA server built in. So this can talk directly to your SCADA systems or directly to a historian without going through the control system and then the web server. And I'll demonstrate the web here in just a minute. So now that that's done, I come over here to my networks. I tell it that I want to talk to this PLC. Now it's talking to that PLC. Now what I'm going to do is I'm going to go to the PLC. Now I'm calling upon some old days when I was a controls engineer. I had about a 35 motor project. And with that 35 motors, I had to do the stop, the start, had to build up all the tags or they tie them to the real world IO. And I had about 35 of them and they were pretty much the same thing, stop, start, fault, e-stop, so on and so forth. But that was for 35. So it took me a little bit of time of building that up into the tag display. But let me show you the power of TI Portal when you use Profinet. Notice this is the tag display. So I'm going to kind of loosen that guy up here, bring him over. I'm going to go to Simicode, and here's the Simicode. And then I'm going to come down here to IO addressing, and then I'm going to say create PLC tags. Okay. And once I hit the create PLC tags, the tags are automatically generated. Now that's the bomb. That's a geek spasm right there, Sean.
That is such a huge time saver. Yeah, absolutely.
And so if I got 30 of these Simicodes, I go to the next one, right click and say, but now where did these tags come from? Where they come from to be created? So I come here to control device. Oops, sorry, pardon me. I come here to the Simicode Profinet. Let me open this up a little bit. Sorry.
Yeah, I think it's control device 1.
Yep, thank you. And I come to parameters. And I go to outputs, and I go here to cyclic send. And now I will line that up. So now you can see exactly where that came from. So there's your on, off, off. Now what happens if you later down the road, you say, hey, I want to add a tag and we're going to go, let's do that execution stop command that I was talking about what this does. So I told it to execute a stop, but it continued to have current flowing. I want to add that tag. So I hit OK. Now notice it didn't instantly put it here. What I have to do is I got to go back to the Simicode and say create PLC tags. Now it's going to bring up a little box that says, do you want to overwrite the existing ones or do you want to keep them and just add the ones that are missing? I want to keep them and add the one that's missing. And there it is, done.
Yep.
So that's a little geek spasm for me, but I can't believe the time savings on that. And that's the power of using TI Portal with the one database, being able to pull in, create tags. Now, FYI, the tag generation also works with our soft starters the same way. And that's about it for it. Let me show you now the web page. So now I've gone in here. Here is the web page. I've typed in 192.168.1 and I'm communicating to the Ethernet IP version. Hit enter. And we enter in here. Now we have with a web page, I have devices okay, buses okay, the PLC DCS is in run mode, and then I'm off. So, and as I did earlier, I can start it. And now I have an on, start as active. Here's my phase sequence. Here's my faults. And this is where it'll list the 21 faults and time and date stamped if you need to, or sorry, pardon me, this will give you the digital inputs of letting you know if there's any faults out there. But then I can come here to the error buffer, sorry, and this is where it'll show me the 21 faults, time and date stamped. Then I have my maintenance and statistics data for this, and this is where you can get some of your OEE calculations. So like for instance, it's going to show me down here, my device, my demo has been running for 145 hours, and my motor is operating at 4 hours. So if that pump is not running, I'm not making money. So help me understand and justify the delta between operating hours of the SIMOCODE, meaning powered up, versus the motor being running. And then here's the number of overload trips. Here's the number of starts. So let's say we have a NEMA starter and we go look and we know that we need to rebuild the contactors. We can go look and kind of do an approximation at after 500 starts, we need to go buy a new rebuild kit for the NEMA starter to rebuild the contactors, or 600 starts. So we can start getting some run rate data with the SIMOCODE, giving it to you to show you to where you approach it. Instead of having a failure in the field and everybody's running, looking, trying to get things going, we can do some predictive maintenance with this type of number of starts and so forth. So here's your kilowatt per hour. And then we can look at some measured values. And this is all the website. And all this is just a checkbox in the configuration of the SIMOCODE, both Ethernet IP and Profinet. So here's your voltage. Here's my currents flowing. We could mess with the current a little bit. I've got some potentiometers. I can change up the voltage a little bit. And then notice too that I have an RTD module. So now I have a max temperature of 32 degrees. I'll drop this into my palm of my hand here and see if we can get it to raise up in temperature. There it goes. Takes a couple minutes. I am a little cold-blooded.
Only kidding, only kidding.
Yeah, I know. But here's your apparent power. Here's your active power. And then again, your faults.
Just in case the audience hasn't noticed, that was in C, not Fahrenheit.
Yep, it is in C, and unfortunately I can't turn it to Fahrenheit. It's hard coded as C. And then I have the warnings. So then here's the warning table letting you know we're coming up on something, and then status information.
Lots of stuff.
And then the control status. Well, I think we've showed enough stuff this time around for it. I hope this has been pretty enlightening for what SIMOCODE can do, talking to both PLC platforms and giving you the data that you need out there. And Sean, thank you so much for allowing me to do this today.
Yeah, you can definitely tell that adding it to the Siemens is just like, boom, it's all there, you generate tags. But I gotta say, adding it to the Rockwell was not that hard either. I mean, you just input a couple of files, which you do with really any third-party device, and it was good to go. So, no, I really appreciate you coming back on. The presentation, going through the product features was good, but it was great to come back on and do this part too, and actually see you use this device with both Rockwell and Siemens PLCs. And I'm assuming you probably could use it with other PLCs as well, as long as they talk Profinet or they talk Ethernet IP. But I guess, is this something I've heard a lot of rumors out there that a lot of these electronic overloads are back ordered. How about you guys? Do you guys have these in stock, or are they long lead time?
Our not lead time is relative. Right now, our majority of our parts are within a week or so. We do have a couple of our CTs that are out about a month, just due to not because of shortages of materials, but of overwhelming orders. But right now we're about a month out on the 10 to 100 CT range and the 20 to 200 CT range. But the SIMOCODEs themselves are on the shelf, ready to go, and all the digital modules and cables are all ready there too. We just have two items, the CTs, that are a little bit longer out, about a month. And
Okay, great.
but other than that, it's just due to of popularity, and we're trying to catch up with the orders that we have right now. One last item too, and before I say goodbye, I've failed to mention that we do have, as the EDS files and the UDTs, we also have an AOI for the SIMAcode also for you
all right.
Rockwell users.
Oh, all right. Excellent. Excellent. Yeah, that would be something too that would save you even more, make it even easier for you. And that's excellent. Folks, if you're interested in this, call your local Siemens representative and ask them about it. I'm sure they'll be able to get you information and price and availability. And Mark, I want to thank you. This was a huge time commitment on your side to come on the show and do the presentation, then come back on and do the demo. And I know you had a lot of pre-work you had to do behind the scenes. So I really just, me speaking for the audience, I just want to thank you for all of that and bringing us up to speed on this product line.
Thank you again, Sean, for all that you do. Have a great rest of your day.
Well, I hope you enjoyed this episode, and I want to thank Mark for coming on the Automation Demo Show to give us a full demo of how to integrate the SIMAcode with both ControlLogix and CompactLogix, as well as S7 PLCs. With that said, if you did enjoy this episode, please give us a like and a sub. And if you want to follow me or get in touch, you can do so over at automation.locals.com. You'll also find all my training courses over at theautomationschool.com. With that, I want to wish you all a very happy, safe, and healthy week. And until next time, my friends, peace.